More scopes was a god of scopes. Signals to the God of signals. something. Can we do something? Yeah, we can. You know what's the day today? It's a day of black magic. Any idea what's going on? Where are my students, for example? Huh?
With your body, you are disrupting the magnetic field around the
Not magnetic.
electron.
Actually, I'm copying famous thing. It's a Theremin's experiment. Later, Theremin used it to create his music instruments called Theremin box. I'm recreating the Theremin schematic without volume control, only pitch. One of the black magicians. Many knew Tesla. Someone listened about Zvaritins, and very few remember Theremin's. It's one of the Theremin's was very capable, very reclusive, and the two things what Theremin's are famous with. This and the thing when don't speak on secret. Oh, you wait. We are doing a black magic here. Famous Theremin's toy. Still produced in Japan. Theremin box are very popular. And are still produced. But why? It's here. What I'm illustrating. Yeah, I'm doing it to make you bored. It's for better sleep. Couple years ago I was promised witch hunter visit for this. See, it's a lot of stuff here. I need to explain what's going on. Yeah? I can say it's a demons. I just summoned a pair of demons, encircled them in a ball, and ball is singing. There is several parts. First part is this, on the right. I have a vowel, a cathode, plus 250 volts, capacitor. What's this? Any idea? What can do this network? This pair of coil, maybe I can come. One moment. I'll take my camera and I will come closer. Here, coil, actually it's a transformer, nice toroidal transformer. 100 years old. It's original, it's not a reproduction. This variable capacitor, it's not so old, only 1955. Valve, this neon lamp acts as a voltage limiter. So here is the circuit number 1. Ideas what can do such circuit? What do we see here? Amplifier loaded with resonance, making radio. It can be, actually it can transmit if you add antenna. We saw it when we spoke on circuits with feedback, yeah? System with feedback. It's a system with positive feedback. It will act as a oscillator. It generates a signal kind cosine omega 0. And what there was at the first glance, omega 0 will be 1. Here I need a square root. Because this part is selective. Here on the right scope, I can bring camera close. Here on this scope, can you see the right scope? Yeah? It's an output signal. It's a signal of this network. Its frequency approximately for about 500 kilohertz. It's here it is my where am I? Yeah, where am I? Here am I. Here is my network number 1. It's a generator of harmonic signal. You can see the signal on the right scope. On the left side, actually this thing is someone, yeah, here it is. This thing was someone diploma in somewhere in 60s, or maybe it's made on purpose. There is one problem with this, with such kind of network. The problem is what load is directly connected to only. This contour is the only element responsible for frequency. So we will see problems with frequency stability. Because everything equivalent quality of this contour is affected by the load. On the left side, I I have some bit different network. Maybe better draw it in opposite. I have a variable coupling here. On the anode side, I have a resonant contour with model coupled output. But here, I have bit more complex this erga, it's not so important. Here is schematic of the left side. On schematic of the left side, I also have a circuit with positive feedback, auto transformer. I draw it. But here is what's the trick? Selective network, amplifier, linear amplifier, selective network. And load is connected not to the network where the feedback is working. In general, it's idea one transfer function, amplification, second transfer function. Feedback. Something like this. If you take two transfer functions and connect them in series, your resulting transfer function will be what? The product. They are multiplying. So here, in such network, chamber is an auto. It's a Chamber's network. In such network, I will have what I will got? Less distortions and more stability. Because load is not affecting directly feedback. And I have two selective networks. Yeah, I need to adjust them to the same frequency, but this gives me more precise frequency control. With, frequency will be more stable. I did a trick. I've attached my nice ball via capacitor to this contour. When my hand on the, I need to pull it, left scope is showing output of this circuit. Here they are, both. If you can see, they both produce nice harmonic signal. What's next? I have one generator, I have second generator. Right one is a fixed one, left one is controllable by frequency. I create a sum of them. This is yellow line, say, for my scope. It's a yellow line on a big scope. You see something like sine, isn't it? On a 1 time scale. Different, isn't it? What is yellow line? What do we see? Here I'm operating with the set of simple signals. Both are harmonic, you can see them. I can do one trick. Let's say I have something like S marks. Here I draw sine of omega. I have something like this. What can I do? I can What can I do? I can assume what this time signal is a projection of vector on a complex plane rotating with the speed of omega. Yeah? Shadow of the vector. In some different time moment. Have you heard what harmonic signal can be represented or assumed as a projection of some vector on a complex plane? I have a sum of two harmonic signals. So I can try to do something like this. Let's say signal 1, this is signal 1, and its frequency rotates with frequency omega 1. This is signal 2 rotating with frequency omega. The sum here is S1 plus S2. Yeah? What will be magnitude of this red vector? It will be square root S1 max square plus S2 max square minus 2S1 max S2 max cosine of the angle θ, the cosine of this angle. Yeah? Am I writing cosine theorem correctly? And what is this angle? That actually is, let's say, omega minus omega 1 time. Yeah? So, amplitude of this nice vector will be cosine of frequency difference. it's a beat signal. Actually, we can assume that S1 is still. That means that S2 will rotate relatively with the differential speed, and this vector will pulsate as a cosine of frequency difference. The closer my hand, as my hand is closer to the ball, is higher is capacitance of the contour. Higher capacitance means higher inertia. Higher inertia means lower frequency. Lower frequency means higher difference. If difference go up, here will tone goes up. The only problem, the yellow line has a frequency around 500 kilohertz. I need to add something to my network. So I have two generators, one adjustable, plus network. Next network is very simple. So-called detector. I need to separate the border line, or I need to extract and magnitude. This one is a second signal on my scope, the blue line. After so-called detector circuit, we see a blue line. Frequency of the blue line is in hertz. Now only amplify and here it will be. Where is my small object? Tiny experiment. See what I got? Disassemblable condenser. Ground wire. My hand is conductive. Book, conductive. Book is not conductive. Why? Stop protesting. Stop crying. Why it's reacting to the glass? Glass is not conductive. Who learned physics? Who learned physics well? Why this thing reacts to the glass? What a silence. Ух. What changes? In capacitance formula, epsilon 0 epsilon. Epsilon is electrostatic conductivity of the environment, yeah? Glass has a greater conductivity. Paper has a greater conductivity. Small change. It's a relatively small change in environment conductivity. But here it multiplies. And we can hear it. We can see it and we can hear it. demo of black magic. When we speak on black magic, actually we should start. This is example of two-signal mutual effects. When we observe, let's say, co-effect of two signals. Theremin's experiment is good, but it's pure, because both signals are harmonic. In near future, I hope we will be able to see more effects. But first, at start, I need to take a look on one special thing. Before we speak on more complex signal, I need to, let's say, take a look on a roof or umbrella theory for this thing. And what's umbrella theory? In general, any signal. Here, I took a small example, and on that example, what we saw? What mutual effect of two ideal harmonic signal is something complex, and in some degree harmonic, but it's a complex thing. Before I'll speak on common effect, I need take one question. And it's a question, relation between signal and its energy. Before I can go further, let's say I have a signal loaded with 1 ohm. Here will be total energy. Let's say double is a total energy. So let's assume what Ks omega is a result of Fourier transform of my signal. I have my signal loaded with 1 ohm resistance, and I knew the signal spectral function. This my I took them. For the whole time of existence, total energy will be integral from minus infinity to infinity square of my signal. But I can write it a bit different way. S multiplied by 1 divided by double P, integral from minus infinity to infinity, my signal spectral function, a power j omega t, d omega, and here in time. What did I wrote in square parentheses? Maybe I'll switch. Total energy, my signal, and this part is inverse Fourier transform Gs from omega, my signal, but as inversion of its spectral function. If I change the sequence of integral, I will be able to write my energy is 1 gain double P minus infinity to infinity. My signal spectral function omega minus infinity to infinity. My signal a power j omega time. Who can tell me what's this? What I got in the blue cloud? What's this? Huh? Any ideas? What's in the blue cloud? No idea. In the blue cloud I got famous Fourier transform, but only with one nuance, with minus frequency. I have my signal spectral function in blue cloud, but with negative frequency, because there is no minus sign here. I'm always worried about this minus. I always check with my notes. So this is spectral function with minus. Or conjugated spectral function. Conjugated. I can write my energy is 1 divided by double P minus infinity to infinity. My signal spectral function, but conjugated, the omega equals to 1 divided by double P minus infinity to infinity square of the absolute value. Finally, I can write what? Energy being integral minus infinity to infinity equals to 1 divided by P due to symmetry. I'm going to integrate it from 0 to infinity. Absolute value of my spectral function square the omega. Name of this is a Parseval's theorem. Parseval's theorem connects signal in time, energy of signal in time with its representation in a frequency space. Based on the Parseval theorem, characteristics is introduced, named spectral density of the signal, energy by frequency. Square. Next time you'll see something on TV, talking or someone showing, for example, spectrum of mobile communication or something about radio frequencies and so on, you'll see watts or possible milliwatts on a vertical and megahertz or gigahertz on horizontal. It's a chart of spectral energy density. Energy. It will give you a chart. Watts, hertz, megahertz, gigahertz, and so on. How energy is distributed as a function of frequency. Usually it will be in decibels. Problem, but you cannot, for example, you have Wi-Fi router. Can you measure it in volts? Hardly. In amps? What's this? But in energy transmitted during communication, yeah, easy. So Parseval's theorem is a base for, let's say, it's not volumetric, it's a space transmitted radio wave energy, power in watts, milliwatts or gigawatts per frequency in hertz or gigahertz. Energy distribution as a function of frequency. It's characterized medium. One of the things why it's interesting, because it gives us a representation of media exploitation. Okay, let's go forward. And in forward, question, what will happen if I have two signals? Not one, but two. Let's say I have S1 and GS1, a result of Fourier transform of this signal number 1. I also have some second signal and as a function of frequency is a result of Fourier transform from this signal. Now it's question, what will happen with S1 plus S2? What do we see in case they are working together? Or acting. Maybe acting is better. So, on the base of Fourier transform linearity, I can write what minus infinity to infinity S1 plus S2 square equals to 1 double P. I should integrate in infinite margins S1 from omega plus GS2 from omega square the omega. Since Fourier transform is linear, so transform of the sum equals to the sum of transform, I can write a Parseval's theorem without any doubt. I need to take into account one moment. I need to open square of the module. I can do it knowing what What? So omega plus GS2 from omega squared can be substituted with GS1 from omega normal plus GS2 from omega multiplied by conjugated GS1 plus conjugated GS2. If you multiply complex value with its, let's say, mirror or conjugate, you will get square of the model. Now I can open parentheses in my equation. And I will get a lot of everything. I will get infinity S1 time plus minus infinity to infinity S2 as a function of time and time plus double infinity to infinity S1 S2 in time equals to 1 divided by double P square in time. This is not right. Here I'm integrating from minus infinity to infinity. So 1 from omega GS1 conjugated omega, the omega plus minus infinity to infinity GS2 as a function of frequency, GS2 conjugated as a function of frequency, the omega, and one more should appear. It will be minus infinity to infinity GS1 as a function of frequency, conjugated GS2 as a function of frequency, plus GS1 conjugated as a function of frequency, non-conjugated as a function of frequency, the omega. Yeah, here it is. I wrote it. Looks like something what can summon a demon. Yeah? But we should not be so afraid. I can take a yellow chalk and put this nice integral into the cloud. I'm doing it to mark this one. What can you tell about two yellow clouds? Any idea? They're equal because it's a Parseval's theorem. It's an energy of the first signal. These two are equal. I will take a blue chalk, draw this, draw around this, and they will be equal. It's a pure energy of second signal. What does this mean? This means what? Red cloud equals to the red cloud. Yeah? What's in the red cloud? Neutral energy. It's a part of common energy. what is determined by coupling effect. So, integral minus infinity to infinity. Signal meter energy equals to 1 divided by 4p minus infinity to infinity, and here I'm writing 1 from omega conjugated omega plus gs1 conjugated gs2 simple as a function of omega, and here the omega. Relay. It's a relay theorem. If you ask Google about it, it will first throw you into the optics. Coherent or non-coherent light source. Something familiar? Huh? What are coherent sources? And they produce an interference. Yeah? If they are in common environment, they interfere. Any signal in common environment, if this energy, you can call it an energy of interference, is not zero, they are coherent and they produce interference effect. When you have here for example, coaxial cable, you would like to transmit multiple TV programs through this cable. If they are coherent, you may face problem because mutual energy will disturb quality. Yeah? But analyze this parenthesis as a function of frequency, you will see here. Can I switch my one moment. And where are you? A red line is a spectrum of yellow signal, spectrum of sound. This one, can I make it? The red line is a result of the DFT of the yellow signal. When frequencies are close, see, these two. The frequencies are close. Actually, we have a double line here, but these two. Coupling or interference effect. If I make here, difference is huge. You see them? No. Oops. Now they are coherent and they're producing interference with quite serious energy. Take another kind of signal, and this one will be so small that it will not disturb any signal with zero interference energy. I can call it interference energy because it is an interference process, or non-coherent signal. They form an orthogonal system. I can use them as a base for Fourier decomposition. It's a rule, but not another way. Sine and cosine are making or world famous base for Fourier laws, but they are coherent. There are no guarantees what if you use set of sine or cosine for your transmission, what there will be no interference. No, you need to set spaces or safety gaps. You need to separate frequencies so to prevent side lobes of your signal to interfere with another one. If you want multiple data or information flows in one media, this formal limits actually will set you a frequency gaps. So be so kind, I don't know, some left for TV programs, for digital broadcasting, something like 10 megahertz is a good margin. Some greedy operators reduce it to 8, but they are greedy, really greedy. Okay, what's this one is not needed. What else? What else? What else? What else? What else? If zero non-coherent may coexist, if below allowable disturbance level coherent but coexistence allowed, above allowable noise level not good, can be used. Where am I? I have some 15 minutes. PTV metal detectors work on similar idea, but changes not capacitance, but magnetic conductivity, magnetic conductivity of the coil. Okay, what I need to do? Ask maybe someone would like to ask a question. Any questions? Maybe. Just small example of two signals. Okay, I see no questions. Possibly enough for today. I have summoned demons. Nice toy. Very good for attracting school children. It has its own magic. This toy and capacitance relay, when lamp switches from capacitance change. Yeah. Okay, I think it is possible for me to press ending soon. Note this spectrum. It's a very character spectrum. Central line and two side lines. Yeah, if someone watching me, the red line, one central and two side lines. We will take a closer look on it in near future. Okay.